Fifth grade lesson 7.6 is fraction multiplication, which I know you're going to like better than you did having to add and subtract fractions because you don't need a common denominator. All right, let's get started. Our essential question is, how do you multiply fractions? Let's unlock the problem. Sasha has 3/5 of a scarf left to knit. If she finishes half of that today, how much of the scarf will Sasha knit today? We're doing half of is a multiply word, 3/5. So 1/2 of 3/5. How much of the scarf does Sasha have left to knit? She has 3/5. It says right here she has 3/5 left to knit. Let's do a different color. 3/5 left to knit. So she has 3/5 left. Of that fraction that is left, how much will she finish today? She's going to finish half of that today. So she's not finishing all of it. She's finishing half of it. One way we could do this is use the model like we were in the previous lesson. We can shade 3/5 of the model yellow. I don't have yellow. How about green? Okay. 1, 2, 3 out of the 5 is 3/5. Draw a horizontal line across a rectangle to show 2 equal parts because now we are cutting that in half. Each of these is getting cut in half. Shade 1/2 of the yellow sections blue. Okay, so here's half of one of those sections, half of the other section, and half of the other section. They want me to count the sections that are shaded twice, one's green and one's blue, and write the fraction. There was 1, 2, 3 that were shaded twice, 3. Out of how many total are there after I split it all up? There's 5 here and 5 here, so that's 10. 3 out of 10. That's really what we did in the previous lesson. That's what we were working on, is modeling that. Compare the numerator and denominator of the products with the numerator and denominator of the factors. The product is 3. Let's look at for the numerator. Let's look at the numerators of the factors. 1 times 3 equals 3. Oh, well, that's true. 1 times 3 does equal 3. Okay, let's look at the denominators. Our product denominator is 10. And let's look at the denominators of the factors. 2 times 5 equals 10. Oh, wait, what? Are you telling me that all I need to do is multiply my numerator times my numerator to get the product's numerator, and then multiply my denominator times my denominator to get my product denominator? Yes! Oh my gosh, that's awesome. That's very easy. I can do that. And I'm not sure how the book wants me to explain or describe what we noticed there, but we noticed that the product, over here, the answer, of the numerators and the denominators are like normal multiplication. I multiplied my numerators, got the product of the numerator. Multiplied my denominators, got the product of my denominator. So that was the way I chose to word it. You can word it differently if you want to describe what we noticed, or you can use mine. That's fine. All right, another way we could use paper and pencil. Now that we've seen this happen, you can multiply fractions without using a model. Now that you've seen this happen, multiply the numerators. 1 times 3, 1 times 3 equals 3, and 2 times 5, 2 times 5 equals 10. Ta-da! So Sasha will knit 3/10 of the scarf today. Multiplying fraction by a fraction, right? It's an even smaller amount than it started with, but because she's only doing half of what she still needs to do. So, but yeah, the multiplication of fractions, multiply numerator times numerator, get the numerator product, multiply denominator times denominator, get the denominator product. Easy peasy, lemon squeezy. All right, but Miss Sanchez, what if I have a whole number and a fraction and I want to multiply them that easily? Remember, you can write a whole number as a fraction with a denominator of 1. So, for example, of 5, if I want that to be a fraction, I can put 5 over 1 because 5 divided by 1 is still 5. I'm not changing that value of that number. I just needed that guy to be a fraction for a minute. 10, erase that. Hold on, let me start again. Okay. The number 10, a whole number 10, if I needed him to be a fraction, I can put him as a fraction by putting a 1 under it. And it won't change his value because 10 divided by 1 is still 10. 1,000 as a whole number is 1,000, but if I wanted him as a fraction, I could put a 1 under him, and he's a fraction now. But a 1,000 divided by 1 is still 1,000, so I'm not changing the value. I'm just putting it, handling it like a puppet, making it do what I need it to do. I need him to be a fraction. So any whole number, like 4, I can turn into a fraction by putting a 1 under it. So here I'm going to do that. And now all I have to do to multiply this is I have it now changed to a fraction, and I'm going to do my numerators. 4 times 5, which is 20, right? And 1 times 12. 1 times 12 is 12. And I get 20 twelfths. Let's simplify that fraction, though, because it can be simplified. I notice they're both even, so 2 divides evenly into both of those. I could do 2 divide by 2 to both, but I want to check and make sure there's nothing bigger that maybe can divide into it, so I don't have to do the division twice. These are both multiples of 4. 4 divides into both of these evenly. I'm going to go with a 4. 20 divided by 4 and 12 divided by 4, because 4 will divide into both of those. 20 divided by 4 is 5, and 12 divided by 4 is 3. All right, good. That is simplified, and that's as low as that can go, so that's good. But here it is, an improper fraction. You know, that upside down snowman, when the larger number is on top of the smaller number, the snowman is mad. He's up on his head and he doesn't like it. Larger number on top of the smaller number. We like to have our answers converted back into a mixed number. Remember, this is just 5 divided by 3, so I could do 5 divided by 3. 3 goes into 5 one time, with 2 out of the 3 left over. So my final answer is 1 whole and 2 thirds. So 4 multiplied by 5 twelfths, or 5 twelfths repeatedly added to itself 4 times, comes out to be 1 whole and 2 thirds. So 4 times 5 twelfths is 5 thirds as an improper fraction, but of course we don't want to leave it that way. The snowman gets mad at us. It's converted to a mixed number, 1 and 2 thirds. Here's our try this. They say evaluate C times 4/5 for C equals 2 over 2, 2 halves. And of course this might at first look like a monster, but it's really just a little kitty cat meow. We have C times 4/5, right? But then they go ahead and tell us, like, by the way, C is 2 halves. Okay, and so what they're saying is C, 2 halves. And remember, that's like saying I have a pizza cut into 2 pieces, but I get to eat all 2 of them. That means I get the whole thing, right? That's 1 whole, right? So let's just write that as 1 whole. 1 whole. Okay, because 2 halves is 1 whole. 3 thirds is 1 whole. 4 fourths is 1 whole. You get all of it, right? What happens when you multiply a whole number by 1? Remember, we talked about the identity property of multiplication. Anything you multiply by 1, it stays the same. Identity prop of mult. Anyways, okay, so let's do the multiplication the way they would have had us do it. If we had done it and not seen that that was the same as 1, what would happen? Well, here we've got 2 over 2, like they said, times 4/5. So we replace C in the expression with 2 over 2 to see what happens. But we already kind of know that this is 1, and 1 times 4/5 is going to be 4/5, so we should end up with 4/5. They want me to multiply the numerator, so we have 2 times 4 over 2 times 5, and I end up with, and then I multiply the numerators and denominators. 2 times 4 is 8, and 2 times 5 is 10. And hey, Miss Sanchez, that's not 4/5. I know. Remember, we need to reduce, and both of these are even numbers, so they are divisible by 2. Divide by 2, divide by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5, and ta-da! There it is, 4/5, just like we knew it was going to be because of the identity property of multiplication. So what did we notice about the product? It was 4/5, just like we thought. So multiplying C equals 4/5 is equal to the 4/5 when C equals 2 over 2, also known as 1, right? Because 2 divided by 2 is 1. Will you get the same result if you multiply 4/5 by any fraction with a numerator and denominator that are the same digit? If our numerator is the same as our denominator, that's 1. If my numerator is the same as my denominator, that's 1. If my numerator is the same as my denominator, that's 1. 100 divided by 100 is still 1. So if we are multiplying 4/5 times any fraction who has the same numerator as it does denominator, it's still 1, identity property of multiplication. So my answer is going to be yes, because, how do we want to word that? Because same numerator, we'll just put num there, and denominator, we'll just put denom there, is equiv to the number 1. Okay, so let's practice some together using the share and show, and hopefully by the time we're done practicing, you've got this dialed in easy. I gave some steps here, and I don't know if I'm jumping ahead of myself here on this step here, but it's a pretty simple one, and it saves us from having to reduce too much on the end. So I'm going to show you that step. I'm sure you'll pick it up just fine. My steps for multiplying fractions are change everything to a fraction if they're not already a fraction. Cross reduce, I'll show you what that looks like. And then I have multiply and 2 arrows, right? Multiply your numerators together, multiply your denominators together is what that means. And then if our answer can be reduced, we need to reduce it or simplify it. And if it can be converted, if it's an improper fraction, we need to convert it back into a mixed number. So these are my handy-dandy steps for multiplying fractions. So let's take a look at those in action. We have 6 times 3/8. Remember, 6 as a whole number, we're going to change it to a fraction by putting a 1 under it. So 6 over 1 times 3/8. Now I'm going to cross-reduce if that's possible. Again, this saves you time, and if you forget this step or you're not sure of this step and you skip it, it's no problem because it'll be taken care of down here. It's just a nice little way to get the reduction over here easier because we've got smaller numbers going on over here. So I can look at my crossed numbers that I'm about to multiply and see, is there a number that can divide evenly into both of those, basically reducing them down or simplifying them down. Nothing other than 1 divides evenly into 1 and 3, so no, I can't do it there. But here, take a look, 6 and 8. They're both even, so 2 divides evenly into both 6 and into 8. So I'm going to do that. That helps me with my reduction later. So I have 6 divided by 2 is going to give me 3, and 8 divided by 2 is going to give me 4. So I'm going to go with those numbers. By the way, I'm going to write this down here and not do the cross reduction so that you can see that you're still okay if you skip that step or if that step feels confusing to you. Now I'm on this next step, multiply my numerators and my denominators. No common denominators, thank you. 3 times 3 is 9. Thank you, Mrs. Sanchez, for making me memorize my multiplication facts. 1 times 4 is 4. All right, now I'm down to this convert or reduce. This is an improper fraction, that upside down snowman, so we'll do 9 divided by 4 to find out what we're going to get there. 9 divided by 4. 4 can divide into 9 2 times because 4 times 2 is 8, and I will have 1 out of the 4 left over, and I get 2 and 1/4 as my final answer. Now, back to this one. Let's say I didn't do that weird cross reduction step that you're trying to show me, Miss Sanchez. What happens then? Well, let's do 6 times 3. That's 18. And 1 times 8 is 8. I can divide that to convert it back. 18 divided by 8. 8 goes into 18 2 times because 8 times 2 is 16. There's 2 out of 8 left over. And now you're probably noticing, hey, these are both even. They can be divided by 2, both of them, to simplify that fraction. 2 divided by 2 is 1. 8 divided by 2 is 4. And I still had that whole number 2. And take a look. So I just happened to do my reduction in this cross reduction early so that I didn't have to do the reduction on the end. It was easier because these were smaller numbers. So that's why I did that. That's something you can do in your multiplication with fractions. So I'll be doing that with you on this. But again, if that's not comfortable for you, then skip that step and then just reduce it at the end. We have 3/8 times 8/9. First, change them all to fractions. That's a fraction. That's a fraction. I'm in good shape. Check my crosses. 3 and 9. Is there a number that divides evenly into both 3 and 9? Yes, 3 does. 3 divides into 3 how many times? Once. And 3 divides into 9 how many times? 3 times. Okay, take a look at this other cross. How about that one? 8 divides into both of those. Nice. Okay, 8 divides into 8 once, and 8 divides into 8 once. Okay, so now I have these as my numerators and denominators. 1 times 1 is 1, and 1 times 3 is 3. And my final answer is 1/3, already reduced. Okay, let's go through the steps again. We have 2/3 times 27. Change everything to a fraction. Okay, that's a fraction already, but 27 is not. So I'm going to do 2/3 times 27 over 1. Yes. Then I'm going to cross reduce because it's easier to do the simplification early than it is at the end, because 27 times 2 is going to be a pretty large number, right? Is there a number that can divide, other than 1, that can divide evenly into 1 and 2? No. How about 3 and 27? Yes. If you know your multiplication facts, you see it right away. 3 divides into both of those, doesn't it? 3 divides into 3 once, and 3 divides into 27, because 3 times 9 is 27, right? So it divides in 9 times. Now I go to step 3, multiply the numerators, multiply the denominators. 2 times 9 is 18. 1 times 1 is 1. Oh, and look at there, 18 divided by 1 is simply 18, and that is the answer. Try pausing the video and seeing if you can do this one. If you get stuck, just push play again, and I'll help you get unstuck. If you get it, push play to check your answer. Okay, I have 5/12 and 3/5. Both are fractions already, so I'm going to do that cross-reduce step. I'm going to look at these crosses here. 5 and 5. Well, 5 divides evenly into both of those. So I'll do 5 divided into 5. That gives me 1. And 5 divided into 5 gives me 1. How about this way? 3 and 12. Well, 3 divides into both 3 and into 12. 3 divides into 3 once. 3 divides into 12. 3, 6, 9, 12, 4 times. Now that they have been simplified on their crosses, I'll multiply numerator and denominator. 1 times 1 is 1. 4 times 1 is 4. Oh, I should have made that the same color, 4. And there we go. 1/4, that's already converted to a proper fraction. It's already a proper fraction, I should say, so I don't need to change or convert it. And it's already simplified, so because I simplified early. Go ahead and try this next one. Pause the video and give it a shot. Okay, you've given it a shot. Let's see. Change everything to a fraction. That is a fraction. Done. That is a fraction. Done. Okay. Let's check for cross reduction. A 2 and a 3. Nothing other than 1 divides evenly into those, so I can't reduce that. And 1 and a 5, nothing other than 1 divides into both of those, so no cross reduction going on this one. So skip to step 3. Multiply straight across. Multiply my two numerators. 1 times 3 is 3. And 2 times 5 is 10. Convert it if it's improper. No, this one's proper. It's this, a snowman is happy enough. Simplify it or reduce it if needed. There's nothing that can divide evenly into 3 and also 10. So that's as simplified as it gets. That is my answer. Let's try number 6. Pause and give it a shot. Let's see how you did. We change everything to a fraction. That's a fraction, and that's a fraction already. Let's do that simplification early so we don't have to do it later, cross reduce on the crosses. But there's nothing that divides evenly into both 3 and also 4, other than 1, so we can't reduce that. And there's nothing that divides evenly into 2 and also 5, other than 1, so we can't reduce that. So we skip that step. Multiply numerators and denominators. 2 times 4 is 8. And 3 times 5 is 15. Final step, convert it if it's an improper fraction. No, that's proper. And simplify or reduce if necessary. Nothing's dividing into 8 and also 15. So we are as simplified as we are going to get. That is the final answer. Hopefully you got that time or came very, very close. pause it here and give it another shot. Every time we try it, we get closer and closer. If we're missing it, as long as we get closer and closer and learn from our mistakes, that's what's important. We're changing everything to fraction. This is a fraction, this is a fraction. That step is done. Cross reduce if it's available. 1 and 8, is there anything that divides evenly into 1 and 8? No, because 1 is as low as you can go anyway. How about 3 and 5? No, nothing other than 1 divides evenly into 3 and also 5. Skip that step. Multiply my numerators, multiply my denominators. 1 times 5 is 5. 3 times 8 is 24. Thanks, Miss Sanchez, for making me memorize my multiplication facts. You're welcome. All right. We get 5/24, which is a proper fraction. No need to reduce it. There's nothing that divides evenly into 5 and also 24. So it's as simplified as it's getting. That is my answer. And let's try this final one. Go ahead and go through the steps. Pause the video, go through the steps and try it. And then see how you do. Okay, I'm changing everything to a fraction. That's going to be a 4/1 as a fraction. Check for cross reduction. 4 and 5, nothing divides into 4 and also divides into 5 other than 1, so nothing there. And of course, 1's as low as you go, so nothing there. Multiply straight across my numerators. 4 times 1 is 4. 1 times 5 is 5. Convert it if it's improper fraction. It's proper. The little number is on top of the big number, just the way the snowman likes it. Convert or reduce, simplify or reduce it if needed. It's as reduced as it's getting. Nothing's dividing into 4 and also dividing into 5. So that is our final answer. I hope those practice ones help to practice through these steps and start seeing how those steps work. And hopefully you will find success on your Think Central. Go get it.